Now we are going to begin the track C of today's forum. And the topic of this session is the data unlocks the learning innovation. So it is no exaggeration to say that data is the starting point of all technological innovation. And the education field has been accumulating massive amount of data in order to improve individuals' learning, and data can be also utilized to solve a lot of education-related issues. However, there are some issues that we need to tackle. For example, students' privacy and protection of personal information and security, and the opening of data, which may have negative impacts. And today we're going to have discussions on the impact of data on the overall education system, and we can also talk about the possibility of generating new services utilizing data, and we will also talk about how we can utilize data more safely. We also have three speakers. The first speaker is Ryan Baker, professor from University of Pennsylvania. So he just waved here his hand. And we also have another speaker, Mr. Lee Jonghyun from Korea Education and Research Information Service. And we have teacher Song-seok Lee from Seoul High School. Now let's begin the first presentation. Professor Ryan Baker from University of Pennsylvania will give us a talk on the topic of big data and education. So he will talk about how we can utilize data mining for education and learning. Ryan Baker is a professor at the University of Pennsylvania, and he is also director of the Penn Center for Learning Analytics. He has developed models that automatically detect student engagement in over a dozen online learning environments and led the development of an observational protocol and app for field observation of student engagement used by more than 150 researchers in 7 countries. So we'll listen to the first presentation.
안녕하세요. 제 강의를 들어서 감사합니다.
First of all, thank you very much for joining us to listen to my presentation today.
Today I'll be discussing big data and education. Over the last decades, the explosion in data has transformed field after field, with big data in climate science influencing our ability to track where a hurricane, for example, is going to land, with big data in physics generating petabytes of data per second that help us to unlock the secrets of the universe, with big data in biology helping us to understand the human genome, and with big data in e-commerce helping to sell us stuff. And the moment's arrived when we can obtain and utilize similar amounts of data in education. Apologies, I'm having a little bit of technical difficulty there. A lot of this data comes from interactive learning environments of various types. For example, at the right side, we see assessments, a workbook-style learning environment where students do their homework and get automated hints and feedback. At the bottom center, we see an image from an online course, such as a massive online open course, which combine video and quizzes. The bottom left, we see an image of a game, Physics Playground, where students learn physics concepts by drawing objects that come to life to help them solve puzzles. Top left, we see Alex, a system that helps people learn math and uses modern AI techniques to figure out what a student should be working on. And at the top center, we see Inkits, a learning environment that allows students to explore scientific concepts in simulations. All of these environments create voluminous amounts of student log data, which we can use to analyze what's going on in detail. We also can get increasingly grade and outcome data. This is a visualization from Alex Bowers' work showing a cohort of students in San Antonio, Texas, going through and shows their grades from elementary to middle to high school and eventually their outcomes. We can collect student engagement data. This is an image from the Center for the Science of Learning in Chennai, India, where data on students' engagement during different learning tasks is collected using handheld devices and then input sent to a server to analyze which curricula are better at engaging learners. These systems increasingly create large-scale data, with the log data from these systems used by hundreds of thousands or even millions of students per year in platforms like, for example, in the United States, Alex and Cognitive Tutor, in South Korea, the READ platform, and worldwide, massive online open courses like edX, Coursera, and FutureLearn. We also get things like whole university system data on course taking and outcomes, and whole school district data on course taking, but also grades, discipline, and how that relates to student outcomes. There's a lot of types of educational data mining and learning analytics method, and some broad categories, and I'll talk about the first three in detail in a minute, include prediction, structure discovery, relationship mining, visualization, and discovery of models. In prediction, we develop a model which can infer a single aspect of the data, the predicted variable, from some combination of other aspects of the data, the predictor variables. So for example, we might predict things like which students in a class are bored, or which students are on track to fail the class. And the important thing here is to infer something that matters so that we can do something about it. For example, if we know that a student's at risk of failing, and our algorithm can tell us a reason why it thinks so, we might be able to intervene to do something. And different students might be at risk for different reasons, and we can act on that. In structure discovery, instead of trying to predict a single known thing, we try to find structure and patterns in the data that emerge naturally, with no specific target or predictor variable. So for example, in some learning systems, they'll get data from lots of different teachers, all creating math problems on the same kind of topics. And we can determine which math problems map to the same skills. In a curriculum that can be approached in different ways, for example, a set of university courses that can be taken in different order, we can look at whether there are groups of students who approach the same curriculum differently. In cases where we have online learning with discussion forums, we can look at which students develop more social relationships in those discussion forums, knowing from past research that students who engage more with each other, and particularly on things related to the class topics, tend to do better. In relationship mining, we discover the relationships between variables in a data set with a lot of variables. So for example, if we have a set of courses or learning objects, are there more effective trajectories through them? And if we have a lot of different learning objects or learning topics, learning lessons, which aspects of the design of those lessons have implications for student engagement? Excuse me. There are lots of applications of educational data mining and learning analytics, the analysis of big data in education. Some of the most important ones include, as I've mentioned already, predicting which students are on track to drop out or succeed. Another big aspect is automated detection of various things, including learning, engagement, emotion, and strategy, to better individualize in an automatic way in the learning system. We also have the ability to create better reporting for instructors or other stakeholders, and to support basic scientific discovery in education. I'll talk for a moment about adaptive learning. So adaptive learning, where the system adapts to something about the learner, requires three things. First, determining something about the student. Second, knowing what matters. And third, once we've determined something and we know that matters, doing the right thing about it. So for example, in learning, we can not only infer whether the students learn the current skill they're working on, but also where in the learning sequence the student is, helping us to make sure that we're not wasting the student's time. And things like, is the student wheel spinning, making no or minimal progress despite trying really hard? We can infer complex learning. Is the student learning to solve complex problems that require inquiry skills, for example? I showed inputs earlier. In inputs, the system can actually infer if the student knows how to conduct effective sets of experiments. Similarly, Is the student developing rich conceptual understanding in domains like physics and computational thinking? In the studies listed here, students are playing computer games, and by aspects of their gameplay, we can infer their conceptual understanding. Robust learning. Will the student remember what they learned? It's really important that the student not just be able to demonstrate the skill 5 minutes later, but that they remember it days later, weeks later, months later. This is particularly relevant in foreign language learning, where often vocabulary words don't build on other ones. Similarly, is the student prepared for future learning? It's good if the student can learn what we teach them today, but if they can learn how to learn more effectively and learn aspects of what they're learning that can generalize, then we can prepare them for their future, for a future of complex learning. Metacognition, students thinking about their own thinking. Increasingly, educational data mining methods are used to solve problems like, how confident is the student? Do they believe in themselves? Is the student asking for help when they need it? Really important to ask for help when you need it. Is the student persisting in the face of challenge? Now, I mentioned wheel spinning a moment ago. If a student is persisting and not making progress, that's a problem, and we need to get them to ask for help. But if a student is persisting in a way that we think will lead to success, then we don't want to get in their way. We want to teach them how, we want to encourage them to persist until they can get the right answer on their own. Disengage behaviors. It's been, a lot of work has shown that it's possible to detect, for example, when a student games the system to try to get through a learning activity without learning. We can also infer if a student's becoming careless, making dumb mistakes despite knowing how to do it. People think that carelessness doesn't matter much, but as I'll talk about in a minute, carelessness is actually a really important type of disengagement because it's something that separates among students who know what they're doing, students who succeed from students who don't. And you can imagine that on a national college entrance exam, carelessness is a big problem. Affect, emotion, and context. We can increasingly detect if a student is bored, or frustrated, or confused, or in a state of deep engaged concentration, where they just really focus on the task. Curiosity, excitement, situational interest, joy or delight. And it's possible to detect these constructs solely from students' interaction with the learning system. Using sensors where feasible can increase model quality, but we don't need them. And in fact, they're not useful a surprising amount of the time. For example, reading a student's facial expression can help you tell if they're bored, but not if they're turning their head, not if they're drinking from a can of soda. So what do we do when we know that a student's bored, or gaming the system, or has shallow learning, or any of these things? There's a huge space of potential interventions. One category is stealth interventions that change learners' experiences in subtle ways that the learner may not even realize. For example, and most classically, mastery learning, where we move a student on to the next topic when they show that they've mastered it. Something even subtler that we can do is adjust the difficulty or the learning supports we give students while they're learning based on how they're doing. We can create reports to instructors, course designers, and the learners themselves. On the left here, you see the scalometer from Cognitive Tutor, which displays to both students and their teachers what the students mastered. On the right, the dashboard from Civitas, which is used by universities in the United States and some other countries to infer which students are at risk. At the bottom, we have content from Transfer VR, a learning system that uses virtual reality to do on-the-job, well, for-the-job training for real-world careers. And this visualization you see at the bottom is a report on how the content is doing so the content developers can make it better. And we can use data to analyze what content is working well or poorly, using automated models, for example, to determine which content is learned slowly or has unexplained patterns and student errors. For example, in my work with LF NextGen, my colleagues and I were able to take a set of instructional videos and determine which instructional videos led students to do better on their performance task, on their homework. And we could then pass this information on to the content team. Which videos were not doing well and needed more work, but also which videos were great. And all we had to do was, what we needed to do there was learn why they were so good so we could replicate that. Immediate reports for instructors. This is some of Mingyu Feng's work. The assessments platform can provide reports to instructors on what students are doing well on and what they're struggling on, what the common wrong answers are and how many people made them, and what the right answers were, and who's making it. I actually use that in my own classes, and here you see an example from one of my classes where we do this. And by doing this, I've been able to really help support students because I can look at the data and tell, and you know, as soon as they submit the assignment, I can immediately see who's struggling, who's disengaged, who needs specific types of help, and what the class in general was struggling with, so I can talk about it the very next day. This is really powerful and allows me to really increase the rapidity and specificity of the support I give students. Some of the uses of this. Review the homework, discuss the common errors at the beginning of class. Pick out students who've made errors and ask them to explain their errors to the class, and then compare those to correct solutions. See which students are disengaged and communicate with them. And I've used this system, as I mentioned, in my own graduate level classes. I'm using it this very semester. And in one of my classes, an intro stats course, it led to the best teaching evals that the course had had in many years. Students, we want to show we care about our students. We want to show them that we care. And in my opinion, nothing shows you care better than emailing a student and saying, hey, I just looked at your homework that you turned in 2 hours ago, and it really looks like you struggled with this. Here's some resources, and come talk to me if I can help you. Another thing that you can do with this kind of data is called proactive remediation. Neil Miller wrote about it. It's the teaching practice of identifying exactly what a student is struggling with right now, and then work with that student individually or in small groups. So in the system that Miller studied, Reasoning Mind, students would be working in class on a learning system with the teacher accompanying the data. And if a student was struggling with a specific topic, the teacher could go over right that moment and talk to the student. Another big category, automated interventions, delivered, for example, by animated agents. Here's an example from Inkits. Rex the dragon sees that the student is doing some kind of sloppy experimentation and says, I think that the data that you're collecting won't help you test your hypotheses because you aren't designing a controlled experiment. Or maybe the student is just mashing the buttons and being really reckless, not trying to learn, and Rex says, hey, are you just playing with the buttons? Take your learning seriously, or I will eat you. Rex doesn't actually eat any of the students. There's a huge space of potential interventions. So many things we can do with these models. It's still an open area for the field. It's an area of considerable ongoing research for my lab and for many others. But overall, the big idea is that thanks to the big data now becoming available on student learning and modern data mining methods for exploiting it, which I haven't really gone into much detail about today, but can go into another occasion, we can make inferences about students in real time, seconds after something happens, that are predictive of long-term outcomes. I didn't really get into detail about it, but some of the constructs I mentioned, like gaming system and carelessness, predict student outcomes 13 years later. If we know a student's gaming a system when they're 11 years old, we can know that the first job they take after college is less likely to involve the subject they gamed in middle school. The eventual goal is to track a student's engagement, knowledge, or whatever now, predict the longer-term impact, and intervene to change that impact, to change that longer-term prediction. Intervene to help re-engage students and support their learning, helping to create learning that is more adaptive to individual learners' needs. There's lots of challenges, but there's lots of opportunities as well. So I'd like to thank you for attending and briefly tell you about a couple opportunities to learn more. We have a Twitter and Facebook feed where we publish all of our latest scientific results. If you're interested in seeing them, follow us. We're not going to spam your feed. We don't post except when we have something to say. We have the massive online open course, Big Data in Education, running on edX now. It's completely free to get a certificate, as long as you don't want a verified one. And all of the materials are available on YouTube and on my webpage. We have an online master's degree in learning analytics at the University of Pennsylvania, which you can take from anywhere in the world. And it's designed to accommodate people in time zones all around the world. Just like I'm up right now here late at night in the United States, we have courses and sessions available at all hours of the day for our masters. And finally, all of our publications of our laboratory are available online. Google Ryan Baker. I'm not the American footballer, nor the British real estate agent. Thank you very much for attending, and I look forward to your questions and comments.
네, 발표 잘 들었습니다, 교수님. 세심하게 학습자에게
So thank you very
피드백을
much.
주려고
And
재미와 흥미를 더하는 모습이 너무나 감동입니다.
it was really impressive to listen to your presentation on how we can utilize big data and data mining in order to individualize our support for our students. And it will be really useful to improve the engagement of our students. And these were some of the comments that were posted online during your presentation. Hope to have additional conversation with you after the presentation.
For the next presentation, we have Mr. Jonghyun Lee, a lead researcher of AI Big Data section at Korea Education and Research Information Service. In his presentation titled Case of Data Analysis in the Education Field of Korea, he will introduce cases of data analysis using AI that are being conducted in Korea. Mr. Lee works at the Korea Education and Research Information Service, and he's conducting research to analyze data in the field of education using the latest artificial intelligence technology. He served in a subcommittee for the government's fourth basic plan for nurturing and supporting science and technology talents. He also served as an expert member of Daegu Metropolitan City Big Data Utilization Promotion Working Group from 2020. Let's listen to his presentation.
안녕하세요. 저는 한국교육학술정보원의
I am Lee Jonghyun from the AI Big Data section of Korea Education and Research Information Service.
데이터 분석 사례에 대해서
I would like to share with you the data analysis cases in the education field of Korea.
준비한 내용을 같이 좀 보시면 좋을 것 같습니다. 먼저 순서는
The order of my
세
presentation
가지로 구성이 되어 있는데요. 먼저 첫 번째는
is as follows. First, I will start with the background, and I will share with you some of the data analysis cases.
데이터를 활용한
So these analysis
분석 사례가
cases
중심이 될 겁니다.
will be centered on the data
향후
utilization.
발전 방향에 대해서
And third, I will end by proposing a future
먼저
direction.
배경에 대해서 설명을
First, I will start by explaining you the
최근에 데이터
background.
리터러시에 대한 내용들이 많이 언급이 되고 있는데요.
Data literacy is mentioned often nowadays, and
문해력이라고
in
해서
literacy in Korean, it's 문해력. It's a capability of reading and writing.
조금
the
더
text.
구체적으로 설명을 드리면 리터러시라는
And
것이
to explain to you in detail
이해하고
is
내면을
understanding, reading and understanding, and then presenting that information externally. And this is a similar concept, and we have a concept called digital literacy. So after reading and understanding and representing the text,
텍스트 정보뿐만 아니라
instead of just
어떤 디지털
ending
플랫폼을
as a text,
습득하는지
it is
정보의 가중치를 조절할 수 있는
we
부분을
can
이해할 수
adjust the
있도록
weight of the information depending on the method it's collected and understood and presented in the digital platform.
이해하고
And then,
내면화하고
after reading, understanding, and representing the data,
설명을 정의를 할 수 있겠습니다. 데이터 리터러시 같은 경우에는 과거에는 글씨는
it talks about that presenting the data. So in case of a data literacy,
사람뿐만 아니라 기계
not just the people, but it covers, we have to analyze the data that comes from the machine and from the systems.
그래서
So
거시적인 관점에서 기술 발전의 그 흐름을 좀 설명을 드리면
I want to explain to you the trend of technology development from the macro perspective. So we got the data in the big data in the 2010s, and it was further utilized. And then there has been a spread of AI utilization from 2020s.
실제로 AI 관련된 내용들이 전부 그
A lot of the things that's related to AI is supported by the big data.
그리고 2030년 경우에는
And we think that in the 2030s there will be a quantum computation and neural link.
거시적인 관점을 제가 설명을 드리는
So the reason why I explained to you from the macro
반짝하고
perspective is AI is not just a buzzword that will disappear,
적으로 발전할 것이라는 의미고요.
but it will rather continue to develop. And in case of a concept of quantum
데이터를 분석하는
computation,
속도를 가속화시키는 것을 지원해 줄 것이고
it will
neural link 같은
support
경우에는
to further accelerate the speed of AI. And in case of a neural link,
기기를 통해서 뭔가 데이터를 얻고 수집하고 이해할 수
we
있는 부분들을
collect
생략을 할 수 있는
and analyze it and understand the information using smart devices, but this will enable us to skip this kind of stages. So big data and AI will continue to develop in the future.
그래서 저희가 데이터 생산자 관점에서 한번
So let's look at it from a data producer perspective, how data have evolved from the past. So when there was a communication taking place using the telephone wire, from a producer perspective, we were only able to collect the data from a fixed PC. However, starting from the 2000, with the penetration and distribution of mobile devices, we were able to collect data using the GPS, and then now we use the SNS information, and then we also are collecting data from the IoT devices as well.
물론 이제 데이터가 폭발적으로 늘어난 것뿐만
And
아니라
it is true that there has been a data explosion, and the reason why the big data and AI further expanded was because there was a decline in the data storage cost.
그 지금 화면에 보이는
So what you see here in the screen is a graph
데이터를
showing
저장하는 비용에
a
대해서
cost for storing 1 gigabyte data.
최근에는 1기가를
So
저장하는데
recently it has dropped to $1 for storing 1 gigabyte data.
비용이 들게 되었습니다. 그 의미는 이
And what this implies is that
모든 데이터들을
for companies or individuals, they will have the data, and then when the technology is developed in the future, then they can further analyze that data that they have collected before.
프로그래밍 방식도
And
좀 변화가
there has been a change in the method of programming. So if you look at the traditional programming method, we input the data and that data is processed. So we develop the function to process the data, and
입력 데이터를 넣으면 아웃풋 데이터
if we put that input data into the function, then we will have the output data. So this was a traditional method. For example, if we log in, then we ID and the password for the login will be the input data, and after receiving the ID and the password, we extract the data from the DB and
그 아이디가 회원인지 아닌지
we match the ID and password to a certain member. So that will be the output data. So this kind of a traditional programming method has changed, as it now requires analyzing the big data. So input data and output data are entered together. An algorithm analyzes both the input data and output data and come up with the predictive information. So here I said, I described it as a classifier, but I'm actually talking about prediction algorithm. I sure that you saw it often in the media. Like there's an image of a cat and a dog, and there is a tagging information to classify whether that is a cat and dog. So if that is entered into the algorithm, and that algorithm will distinguish whether that is a cat or a dog. So that is the data analysis mechanism that are used nowadays. So in the Korean Education and Research Information Service, me and my colleagues are analyzing the data in various ways, and now I would like to explain to you about that. So if you look at the data analysis cases that we've done so far, it is about predicting the school accidents and the possibility of getting jobs.
부분들을 연구를 했었습니다. 근데 가장 최근에 저희가 연구를 했던 부분들은
And the recent research that we conducted was about predicting the school accidents.
처음에는 이 시각화에 대한 부분으로 먼저 저희가 의뢰를 받아서 데이터 분석을
We were requested to do the visualization. And if we look at the data analysis that we've done,
학교안전 사고에 대한 사고 기록 내용을 저희가 이제 분석을 해서
we analyzed the recent school accident record and then we made the word cloud
왼쪽에 있는 그림처럼
accordingly. So as you can see on the left-hand side,
영사 위주로 저희가 빈도수를 측정을 해서
we measured the frequency of the words and conducted technology statistics. And then on the right-hand side shows the
발생하는
school accidents,
빈도수를 한번 월별로
the frequency of school accident in 2019.
시각화한 자료가 되겠습니다.
So it's a visual graph showing the monthly school accidents. So starting in March, April, and May, this is when students go back to school. You can see a high number of school accidents, and then it drops. And then in September and October, when students return to school after summer break, the school accidents increase again. So by making a visual graph like this, the teachers who are in charge of student safety can pay more special attention to students, conduct training, safety training to students in March or April.
그리고 저희가 이렇게 구성된 안전사고 학교 안전사고 그 내역들을 텍스트 분석을 했습니다.
And we conducted text analysis of the school accidents, and
그 군집을 만들 수가
we were able to form 9 different groups.
그 수업 시간이냐 아니냐 그리고
And we analyzed it into whether it is a class time or non-class time, and what kind of activity students were playing when they encountered this kind of school accidents. So when we were able to categorize into non-class time and the class time activities. We were able to classify it into a ball game or playing.
사고로 구분이 가능했고 그다음에 수업 시간은 아니지만
Even though it was a non-class time, there were some accidents that occur while moving up or down the stairs. So we did this kind of text lining, and we conducted the group analysis, and we looked at what kind of accidents are taking place.
그리고 어떤 학교에
And
학교 안전 사고가 많이 발생하는지
we also wanted to look at
머신러닝 알고리즘을
in what schools the school accidents happen often.
그다음에 학교
So we looked at the number of school accident cases in schools, and then we also correlated to the type of schools. And the findings shows,
예측 정확도는 그 ROC
well, the
the
prediction
그 수치를 낼 수
accuracy was 0.919.
데이터 분석을 한 학교가 여러 개가
So
있습니다.
there were a lot of schools where we analyzed the data, and that respective school,
확률적으로
we will look at the probability of school accident in that respective school.
학교인지 아닌지를 구분하기 위한 그 기준 임계치를 이렇게 조정을 하게 됩니다.
And we will be making adjustment to the threshold, standard threshold, to classify whether that is a school where school accident happens often or not. And that accuracy shows 0.919, which means that this predictive model has a 92% accuracy to predict the school that is likely to see a high number of school accidents. And in the past, we had, before we adopted XAI, when we predicted, there were a lot of questions related to preventive measures. So how can we prevent this kind of problems from happening? So we got a lot of these questions. So we will structure the factors, and then
영향을 미치기 때문에
we will look at what kind of impact it has on the dependent variables, and then we will suggest some activities to conduct in order to prevent the accidents or issues. But recently we started introducing adapting XAI technology, and then we were able to analyze which factor had the most impact. So if you look at the graph on the right-hand side, the red line shows that indicator is very high, and as it moves to the further right, it shows that there is a high possibility for that school to experience a school accident. So if you look at it, the line from very top,
그 당해 학교
of course, if there's a lot of students in that school will probably see a high number of school accidents. And if there are a lot of students participating in after school, that school is also likely to see a high school accident.
학생이 오래 학교에 머무르기 때문에
And if students stay longer at school, this is something that we can predict. And the middle school
그다음에
also had a high probability of having a school accident. And
그런 부분들에 대해서 학교 안전
if there's a lot of school violence taking place in the school, that school
남학생이
was likely to see a high number of school accidents. And the more male students the school has, the higher possibility for that school to have a school accident. So we did this kind of a text mining, and
학교 안전 사고 데이터와
we looked at the school's
일반적인 데이터를
school safety data and the general school data,
그다음에
and we built
비정형 데이터
in all this to make
요
predictive
그래프는
model.
향후에 데이터 이 빅데이터 구성이 어떻게 바뀔 것인가에 대한 예측 내용.
So this is a forecast on how
데이터라고 하는 거예요.
data analysis will change in the future. So there's a structured data like a number. So it's typically the number that is used in Excel. So unstructured data is referring to text or image or videos. So if you look here, you can see that the 80% of the data is unstructured data.
주로 인터넷 뉴스라든지 댓글에 대한 그런 텍스트 정보를 좀 분석을 할 수 있는.
So we can analyze text information like a news on the internet. But before talking about that, I want to tell you about why this online information is important.
최근
If we look at
그때부터
the poll here,
이 추세를 보면
and which shows the trend from 2022 of the influence on public opinion. So
있긴 하지만
you can see that the TV had the most influence on public opinion, but the influence of internet news on public opinion is increasing as well.
인터넷 뉴스에 대한 데이터들을 좀 분석을 하기
That is why, in order to analyze, we conducted study to
뉴스를 분석을 한다고 하면
analyze the internet news data.
많이 출연하는 그런 빈도수가 높은 단어들을
So
분석을 하는데요.
we
이런 분석의
typically look at the number of search words that occurs often.
어떤 의사 전달을 한다고 했을 때
So when human want to communicate something, the human will use the word that he intends to deliver to the other people. So typically in a speech, we analyze what word is used often. But when we apply this concept to the internet use, there can be some problem. So let's say there's an abusing news. So abusing news that's often inquired in the media that quickly spreads.
복사본처럼 이렇게 계속 그 복사 형태의 뉴스를 발행을 해서 조회수를
So it's like a copy news, and then that is intended to increase people's
저희가 구하는
searching
댓글 수
for that news. So in order to prevent that from happening, we looked at the articles that had many number of comments, because
그 의견을 많이 달고 있습니다.
people usually post comments that are
보도된 자료에 대한
to oppose to what is posted on the internet use.
좀 정확하게 분석할 필요가 있고
So
그런 부분들이
we need to accurately analyze the comments of the policymakers.
이해도가 떨어지는 분들의 의사결정에 미치는 영향을 분석할 필요가 있습니다.
So we need to make
얼만큼의 댓글이
analysis of the decision made by the people who are lacking understanding about the article. So we conducted the
숫자를 이제 회귀 분석을 해서
analysis, and we conducted regression analysis and came up with the finding.
그 인식을 1 정도 바꾸기 위해서는
So in order to change the recognition awareness of the
저희가 조사를 할 수가 있었습니다. 그래서
people who are less involved, we can see that the comment has an impact. And
일자별로 기사가
on the left-hand side shows
산출된 그래프를 시각화한 것이고요.
the internet news in education on a daily basis. And if you look at the right-hand side graph, you can see that it is different.
비정형 데이터에 대해서도 좀 분석을 하고
The right-hand side shows that importance as an index. And if I share, well, the limitation of this approach is that we crawl the data and accumulate the data, and we can only analyze and come up with the finding using that sampling data. So in order to generalize it, we use the Python program.
CINet이라는 프로그램을 많이 쓰는데
And typically people use UCINet, but we use the Python library. So in the previous week and this week, we will check whether there's any difference in the articles or the news, and among what was posted,
댓글의 내용에 통계적으로 차이가 있는지
we'll look whether there is any difference to the comments that were posted for that news.
예, 그리고 마지막으로 향후에 저희가 그 초중등 지금까지 이제 교육 행정에 관련된 부분.
So I've talked about the education administration related area, and now I would like to talk about preparing for the
교육 분석 방식은
basic education and the secondary education. This is what idea that I have about the
각 문항에
future direction. So for the questions, we analyze the probability of the student solving the question using the item response theory.
의미 있는 의견들을 분석을 하고 있는데
We
그런 플랫폼 자체가
did this kind of an analysis.
수학이라든지 과학이라든지
So,
이런 과목들을 잘할 수 있도록 도와주는 형태로 구성이 돼서 운영이 되고 있습니다.
We
저희가
have structured it so that students can have a better learning outcome on subjects like math and science. So what I would like to suggest to the institute is that this data can help students to have a significant learning experience. So
개념을 연결하고
we can link this with the concept of fun and excitement.
그 교육공학에서 얘기하는
And
교육공학에서 얘기하는 교육공학에서 얘기하는
sorry.
학습 도구들, 학습
And the learning tools or learning environment that's often described in the education engineering. So this is an example of a learning environment, the realistic issue and the actual cases and the cognitive tools and information resources. So all that can be combined to offer the right learning environment for students. And then
정구적 문제가 아니라 비구적 문제까지도
students will also become interested in the issues that they have not encountered before, and they'll be able to solve those problems and other problems that they will encounter in the reality. So that is the way that we want to complement and further refine our system. So we have designed the system in such way. So things like competitions or data sets, programming, community, ranking, and curriculum. So for each of this, there is a coding method, and there's also no coding tools for students who find coding very difficult. So we have designed the platform in such way, and we plan to further upgrade this platform. So my time is up, so I'll finish my presentation here. Thank you very much.
연구원님 발표 잘 들었습니다.
Thank you, Mr. Lee.
댓글을 남겨주고 계시는데요.
Many participants are posting comments.
연구를 많이 하고
I can see that you are a leader in conducting a lot of high-tech researches regarding Korean education. So
실제로 적용하는 것에도 관심을 가져달라는 말씀을
It'd be good if many people pay attention to applying this kind of research. So I'm curious to know actual effectiveness and what kind of impact there was by applying this kind of research into the realities. We'll cover this in the Q&A session shortly.
서울고등학교 송성리
Let us listen to the final presentation of this morning's sessions. The speaker is Mr. Song-seok Lee, a teacher from Seoul High School, and he will talk about the ability to read and write data literacy. And he's going to talk about data-based convergence education. He believes digital technologies, community, and civic engagement can transform the public education. He is also working as a director of Kakao Impact Foundation. Now I'd like to invite teacher Seok Lee Song onto the stage. Hello everyone, I'm Seok Lee Song from Seoul High School. I'm going to talk about, as many have already presented, the data literacy and data-based convergence education. If you're interested in education, probably you're familiar with this slide. And this is related to 4C, communication, collaboration, and critical thinking and creativity that are critical for future talents. And we need to think about how these 4Cs can be nurtured utilizing data. We all realize that we are living in the era of data and AI, and many people already talked about how AI can innovate education, as was shown in the case of AlphaGo beating the human Go player. Of course, there are some problems and issues that AIs can tackle better than human beings. But when it comes to problem solving, of course, we believe that AI can solve problems, but that is only possible when we have data. Then in public education, we should be able to utilize data and AI in education. And I'd like to mainly talk about data. And because we need to understand how we can use data to identify and define problems. And there was questions some raised. We need to also understand whether we'll be able to agree with the decision made by AI, and we should be able to evaluate the outcomes that are generated from AI, and all of these should be included in our public education. There are a lot of interesting AI applications that are already available, but instead of talking about all the nice fruits or tasty fruits, I'd like to more focus on the root part of this tree, and I'll share with you some of the examples from classrooms. There is data-driven debate. Social studies, Korean language teachers, and I work together on this convergence classrooms, and there is a paper written about this project, and if you're interested, you can find this paper and read it yourself. I'll summarize the key contents of this paper today. In 2020, we conducted this project, and we had to first select the topic of the debate. And it was in 2020, that's when COVID-19 pandemic broke out. And in Korea, there was a lot of controversy over the provision of the relief support for Korean citizens. So it was a really sensitive topic, and we wanted to utilize this topic for the debate class. And this is what we do to prepare for this classroom. We have public data portal in Korea. Not sure whether you visited this website. And for high school kids, it was their first time to visit this website, and there are lots of data available and provided by many different organizations, including the number of confirmed COVID-19 cases. Though this is from 2020, in my school, the students had devices that they can use in classrooms, and starting from next year, first graders in high schools in Seoul will have their own devices. So we hope that this type of classrooms will be further promoted. And the students got into groups of two, and they created one question that they want to find answers to, and they had to find evidence to support their arguments, and they had to find relevant data. Here, they, of course, have difficulties in finding data or verifying their questions, and also they sometimes ask for feedback. And looking at all this information posted by other friends on Classroom, other students in the classroom can provide feedback. Of course, it takes a lot of time to give feedback to students, but we leverage online tools, and then it can promote active communication between students in the classroom. So the Korean language teacher provides the basic instructions for how students should be engaged in debates, and because these debates will take place based on data, and he also provided basic explanations on how they should utilize data in order to engage themselves in debates. And during social justice classroom, there were some explanations and instructions on social justice, and this provides sufficient context on the data that they will be collecting, and this is an important concept that they have to understand in order to perform the task. And there are some basic explanations on important philosophers who talked about social justice, and based on this basic learning, also the students understand the basic concepts of or different aspects of social justice. And this is the outline that students have to write in order to engage in the debate. And of course, they can submit their opinions, but it is the teachers who randomize the students who will be making arguments for and who will be making arguments against the main thesis. And from March to October, this project was conducted, but we were not able to organize online debate classrooms. And we insisted that this type of debate classrooms should be organized on-site in classrooms. But there was a peak in one day in September, and still we were able to organize some offline debates, but most of the classrooms had to get together online in order to proceed with the debate sessions. And we also created individual debate rooms, but at the same time, we organized the big debate rooms, which invites all the students in order to encourage individual students' engagement and participation. And in online classrooms, we also had some positive impacts with more student engagement. Students that analyze this data, and when they are capable of analyzing data, they can engage in those discussions and debate with their friends. And these are some of the ideas that were generated by students. You can see that these students had various approaches for the same topic, and if you look at the bottommost idea, both groups had different or same sets of data, but they came up with different conclusions. And even if we base our opinions on the same sets of data, people can develop different ideas. So data is something that does not provide the finite conclusions to everyone. Rather, different people have different interpretations of the situation. So we converged 3 different topics and subjects in order to organize this debate class. As a result, through feedback, we were able to identify that, of course, we have this Venn diagram, but we had to have the involvement of the statistics. However, unfortunately, we were not able to include statistics. But if you have questions about this, I'll be happy to answer your questions. Now I'd like to talk about
아주 간단한 인공지능을 활용하는 것입니다.
how we utilize AI. Of course, deep learning is one of the highly advanced AI technologies, deep learning. But unfortunately, deep learning is not something that can be understood by high school students. So instead, we incorporated basic AI technologies in the classrooms so that they can use technology to solve everyday issues. We had the involvement of the mathematics teacher, and probably this year we'll be able to organize more sophisticated lectures with the help of the mathematics teacher. In Seoul, we teach our students about the problems of climate change, and we have KMA's website, and we can obtain a lot of data that's related to climate and weather. So do you see temperature is rising here? And even elementary school students can guess that temperature will continue to rise. But how much? People will give different answers because it's all ballpark figures. So we have to identify patterns from data, and to identify patterns, we need to rely on AI and other technologies. On your left, you see the data, and it's dotted graph. From this graph, the mathematics teacher teaches one mathematical concept, and you can extract this straight line from these dots on the graph. So after understanding the basic mathematical concept, students can draw this straight line on the graph, and there's also another machine learning library of Python, and x-axis has the year and the y-axis has the average temperature, and could be also used to extract this straight line from Python. But they do not stop here. We ask them another question. What if this blue section and red sections can be separated in extracting that straight line, and the gradient of the line will change. And because we are witnessing the sudden changes of temperature recently, the gradient of the red zone will be greater than the blue zone. And that's a conclusion that the students came up with. As you see in this graph, the gradient in the blue zone and the gradient of the red zone are different, and the gradient of the green straight line is also different. And students now realize that the gradient will go up as we proceed in the red zone, and they can also realize the seriousness of climate change. Data is not something that is fixed. Rather, we can extrapolate questions from data, and we can also find solutions, and we can also have discussions around the outcomes that we generate from analyzing data. Of course, solving this one problem does not teach a lot to our students about social justice. A lot of schools cannot organize field trips because of COVID-19 pandemic, but if we can organize a field trip, maybe we wonder whether we should bring a bug repellent. So we are already in the season of fall, but still we have a lot of mosquitoes. And the Seoul City government provides data on mosquito indicators, and based on this data, students can guess or predict when we'll have many mosquitoes around us. So this is an outcome of the correlation analysis. Students are interested in the topic of when they will have the most number of mosquitoes in their house. If you look at this table, the mosquito index is high when there is a big gap between the lows and the highs in the daily temperature. So the x-axis is the lowest temperature, and the axis y is the mosquito index, and we can extract this dot. And now, based on the concepts that we learned, we can extract the straight line, and we can also predict the mosquito index based on the assumptions on the daily lows and daily highs in temperature. We also teach our students that if they identify the straight line, and if this type of graphs can be generated, they can also come up with this prediction of the mosquito index. Here, axis is the number of days per year. So January 1st is the first day, and the February 1st is the 31st day of the year. And compared to the lowest temperature model, this type of model can have better prediction for the mosquito index. So this is how we use AI for our classrooms, and this is the last thing that I want to share with you. If teachers have data literacy, a lot of things can happen.
저는 전국에 있는 700분 넘는 선생님들과 함께
I'm working with 700 teachers in Korea, and I'm operating a coding community. And we have members such as students, teachers and IT coders. And this community is named Seoul Lab. And there are a lot of activities happening on this community, and we share what we learned with other members. We had a study for 6 weeks, and this is a project-based project, and 5 projects were carried out. And in the last week, we used the GitHub, and the outcomes were uploaded to GitHub so they can be shared with other people from other countries. It was a free topic and free assignment, and the students, the teachers worked on data-related projects. And this teacher is from Iran Elementary School, and this teacher is really capable with data and coding, and he recently developed a service and opened it online. As you see here, I think you all agree with me, there are a lot of school resources, but a lot of times those resources are not used efficiently, and based on his experience, he coded this application or service so that all those resources can be utilized more effectively and efficiently by analyzing relevant data. Last but not least, of course, I've covered a lot of things today in my presentation, but before I conclude my presentation, I'd like to think about the areas of interest that we need to pursue in the education areas, digital transformation. Of course, the age of data and artificial intelligence already has opened up. Unfortunately, we are not paying sufficient amount of attention to the importance of data, but data is really important, and we need to be able to read data and utilize data, and data literacy should be regarded as an important aspect of our training and education. Of course, I was not the only alone in the classroom. I collaborate with other teachers of other subjects. Going forward, all the subjects should be taught utilizing data, and students should be encouraged to utilize data in order to improve their learning, and we'll be able to improve data literacy of our students. But unfortunately, of course, I do understand why it's happening, but of course, there are some insufficiencies in terms of devices and internet connections, but I hope that there will be further improvement in terms of infrastructure establishment. Only then, our schools, our classrooms, and our students, when faced with new challenges, will be able to find solutions to those challenges by having more interest and training on software and other technologies. So what I would like to highlight is that, so I was talking about the community that I'm operating with other teachers.
아이들에게
when
이런 디지털
teachers are
역량을 충분히
digitally
가르칠 수 있다고
capable,
생각을
they will
합니다.
be able to teach
왜냐하면 단순히 어떤
digital
도구를 가르치는
to our
것이라면 사용
students.
설명서를 보고 알 수
If we are
있겠지만
just
지금 말씀드린
teaching our
내용들은
kids about how to
디지털
use the
세상에서의
digital
데이터로
tools,
문제를
we don't have
발견하고
to teach them
정리하고
because there are
해결하고
always the
평가까지
manuals
해보는
that they can refer
전체적인
to.
프로세스에 대한
Rather,
굉장히
we have to
높은
have a
이해가 좀
better
필요한 부분이기
understanding
때문에
on
아이들에게
the
이런
overall
수업을
digital
선생님께서
technology
진행하신다면 선생님들께서도
processes.
이런 영향을
We'll be able
갖추시는
to
것이
help
중요하다고
our
생각을
students to
하고요.
improve
물론
their digital
정부에서도 최근에
capabilities.
아이에답이라는 사업을
Recently,
통해서
the government
이런
launched a
그
program
프로젝트들을
called
진행하고
IDEP,
계시지만
and
현장의
they
많은
have similar
선생님들께서 또 이런
projects.
제가 말씀드렸던 내용에 대해서 더 많이 공감을 해주시고 그
But
공감을 바탕으로
the projects
저희가
are
함께
different from
먼저
what we've been
선생님들끼리
doing,
이런 연구를 해
and
나간다면 정부의 정책과
teachers getting
선생님들의
together
뜨거운 그런
and having the
반응들이
support
함께
from the
어우러져서
government
우리 아이들에게 정말
will create
디지털
synergy
필요한
effects
교육들이 제공될
and
수
will
있지
be able to
않을까
provide
생각을
better
합니다.
digital capability or
지금까지
digital
저희 발표를
literacy
들어주셔서
related
대단히 감사합니다.
education to our children. Thank you very much for your attention.
네, 선생님 발표 잘 들었습니다.
Thank
정말
you,
열정 넘치게 발표를
Mr.
해주셨습니다.
Song, for your
고맙습니다.
passionate
이렇게
presentation.
현직 교사 선생님들의 발표가 정말 실제적인 도움이 되는 것 같습니다라는 응원의 메시지.
It seems that the
감사의
presentation
메시지
from the
보내주고 계십니다.
teachers
오늘
are
손성리 선생님께서
providing us a lot of
소개해주신
practical
패스와
support.
토론을
We are
토론해
seeing a
보시죠.
lot of
너무너무
useful
고맙습니다. 윤수진
advices
님,
from the
유익한
presenters.
강의였습니다. 주창원
Thank
님,
you for
좋은
the
말씀 고맙습니다.
useful presentation. Thank you for
교육에서
wonderful
저희들을 활용할 수 있는
comments.
대한 멋진 강연 너무나 기대를 하고 있는데요.
I have a
감사합니다.
very high
계속해서 좋은
expectation
말씀
on
많이 해주셨습니다.
your presentation. It was
지금 저희가
worth it.
세션을 계속 진행하면서 이제 실제 교육 현장에서 근무하고 계신 선생님들, 교수님들의
We have
발표를
listened
많은 분들이 정말 공감해 주시고 정말
to the presentation from the
유익하다는
teachers and
말씀을
professors, and many participants agreed to what was covered in the presentation, and they are all saying that it's very helpful for them. And I have a question to Ryan Berker.
So you talked about how we can analyze big data and data mining, and it can change our education. You shared with us many examples, and you mentioned that different educational content, like videos, had different learning impacts. So do you have any characteristics that you identified from those video contents that were really effective to help learnings by the learner?
Great question. So in particular in that study, we found that videos that focused closely on the topic and had worked examples which took the students through the step of what they needed to do in a very concrete fashion that was well aligned to the content were particularly effective. We also found in some of our research on the characteristics of content, of other types of content, we found in particular that it is particularly effective to have content that links to rich context, cover stories, and it's effective to have content with no cover stories. But for example, content with very brief context, like quote unquote in America, hokey math problems, like Ryan buys 5 t-shirts and Yunjun buys 7 t-shirts. It cost $88. How much is a t-shirt? That's really disengaging.
네, 답변 대단히 감사합니다.
Thank you very much for your answer. There's another question to you, Professor Baker. So this is the question. So maybe it is really important to understand how to utilize big data, but interpretation of the analysis should also consider the context, and the teachers understand the context. So do you have any recommendations for the teachers to? So are there any studies that are related to the interpretation of the data by the teachers, or how they should consider the context in interpreting the data analytics outcome?
So there are many studies on looking at how to interpret these models and how to translate them to a fashion that can be used by teachers. Absolutely. In fact, anytime a prediction is given, anytime an inference is given to a teacher or a principal or a guidance counselor or any school stakeholder, they're going to interpret it through the lens of what they already know about the student. And so the key is to give information in a fashion that's actionable and that enables people to kind of to leverage their ability to interpret. So for example, I think that the assessments platform is really good at this because it tells you exactly what the student's error was when they make an error and tries to provide information on what might have caused it. Or for example, some of the at-risk prediction platforms that tell you what variables go into their prediction and what the values of those variables were for the student, so that then the school leader or teacher who's looking at it can say, maybe this is what happened here. So the more that we can unpack the key information about a prediction to give it to the person making the decision so that they can leverage what they know of the context, the more able they will be to use what we provide them.
Thank you very much for your answer. So that was a short Q&A with Professor Baker.
There's so many questions. It's very difficult to choose which question to ask. Now, this question goes to Mr. Lee. You share with us various data analysis cases that are being done in KERIS. So are there any cases that has actually applied in the field? Or what kind of efforts are you making so that these cases can be applied in the field?
좋은 질문 주신 것 같습니다. 일단
Thank you
질문해 주신
for good
연구
questions.
사례가 실제로 구현이 됐고
So I think the question is about whether these research cases have been applied in the field, and if not, what kind of efforts are needed to make sure that these cases are applied in the field.
먼저 답변부터 드리면 아직 이게 보급이 되지 않았습니다.
So it has not been deployed or applied in the field yet
어떤 분야에 어떻게 이
because
알고리즘을 적용해야 되는지
we have not
사례가 많지가 않습니다. 그래서 현재는 그런 연구 사례를
we haven't seen many cases that tells us in which AI algorithm needs to be applied in which field. So we first have to conduct a study about what kind of algorithm can be applied to what field. Unfortunately, many teachers have a keen interest in this area, so this research model can become an engine, so we can just add a program after we develop it and supply that or deploy that in the field. So if teachers continue to show interest, I think that will provide a big support in making it realized. Thank you.
I hope that it will be launched sooner than later. Again, we are getting a lot of comments and questions online. There's another question.
But in US and China, in countries where there is abundant data, so is there any tuning work that is required to apply that in Korea? So US and China, well, we can look at it from different lenses. Let's say a company A has a learned data, and that data be applied or used by company B. So just as I explained in my presentation, AI algorithm is fixed. What's changing is the data. So the data that's being used in US or China, or data that's being used by A, the learned model cannot be directly applied to our country or company B. So that is why securing data and data accumulation is very important, because company like Amazon, they have collected a lot of data from their unhuman stores, right? So where a customer can make payment automatically without the help of human staff. So they cannot be applied to our stores in Korea. And that is why it will take a lot of time for us to do that. It's very important for us to be a first mover rather than follower. So you're saying that it's not compatible, right? Well, I'm a non-expert in this area. So in the You think that can be realized in the near future? No, it's not, because it has to do with the data characteristics. The predictive model just reflect the characteristic of the data into the model. So, for example, in the US and China, and if the Korean student characteristic is very similar, then we will be able to apply it. But if the characteristic is different for a country, then unless we incorporate that difference in characteristic, we cannot apply that data. Okay, I understand why we need to be the first mover.
So, Teacher Song, so you talked about the statistics. So you presented many different graphs. How can we teach, or depending on whether or not we'll be able to include statistics, we'll be able to organize different classrooms in high schools. So how can we do this? So as I explained in my presentation, I think having statistics in our classrooms is really important, because data science is computer science, domain expertise, and science and mathematics combined. Of course, we have domain knowledge of the teachers, and under the current administrations, there are a lot of efforts that are being made in order to improve digital capabilities. We need all those elements in Korea in order to improve data literacy, but unfortunately, we are not providing a good level of statistics in Korea. When there is a set of data, we have to understand the data as it is, but we also need to utilize statistics in order to extract valuable insights from it. I hope that there will be more statistics-related curriculum included in our education, because it seems like mathematics teachers view mathematics, which is separate from statistics, and not just simple mathematics, but we also need to teach our kids the basic statistics. So I hope that statistics will be included in data literacy-related education. So, from whom do you need support? We need support from the citizens, and when there is a lot of public demand, we'll be able to make some changes in our education. Of course, our curriculum is revised and upgraded on a regular basis, and of course, even though there are some differences between mathematics and statistics, we hope to see statistics included in our secondary education curriculum. I hope that there will be an interest from the education authority on this matter. It's time for us to wrap up the Q&A session of this session. So using data, we can innovate the learning and education. I'd like to thank all the speakers for this session. And thanks to your contribution, we were able to have a lot of discussions with the participants. And thanks to your participation and engagement, we really had a successful session. Once again, thank you very much. Well, this wraps up the morning session of Day 3 of EdTech Korea Forum 2022. Now we're going to have a lunch break, and the final session of the forum will resume at 1:10. It's great to see that we also have a great turnout for the last day of this forum, and once again, taking this opportunity, I would like to thank you for your participation. And the final session will begin at 1:10. And in the final session of the forum, we will have discussions on the global EdTech trends, digital transformation for every innovation of education. So I'll see you at 1:10.